In this video, we are going to get rid of this UI, and instead we are going to be able to click on each column to select it. To achieve that, we are going to add invisible regions in front of each column. So let's go back to the code and let's go up to the template. So right before this div class row, we are going to draw another set of divs, one for each column in the board. So let's say div, and let's give this a class of column. And here we can do another v4 column and column index in board, and we can just select one of the rows. Let's say the first one. Let's give it a key of column index. Now for the style, we're going to use column style to make it programmatically, and we can open and close curly brackets, and in here we can say left, and this will allow me to offset each column by a certain amount, and that amount will be the column index times 50, because 50 is the width that we chose for each of the blocks in the board. Now the left CSS property only works with pixels, so we have to add px at the end. Now for that to work, I have to give this div a position of absolute. So let's go ahead and do that. Down in the style section, we're going to say column position absolute. But if we just do this, all of the column divs will be aligned completely to the left. So we have to align them relative to the parent. To do that, we have to give this board class a position of relative. So all of the columns will be offset from the left from the boundaries of the board. So down in the style section, let's add a class board and make it position relative. Now this key over here is going to give me an error. So I'm going to save this, and if I go back to the browser and see the console here, you can see a bunch of errors, and it's complaining about duplicate keys. You can see that it complains for the first 5 keys, and this is because the values for this column index are going to coincide with the values of this other column index. And VueJS needs unique keys for all of its loops. An easy way to go around this problem is by making this key unique, and we can do that by simply prefixing it with a unique value. For example, we can use call dash and then column index, save, and if I refresh, that takes care of the problem. And by inspecting the elements of the page, we can see that we have 1, 2, 3, 4, 5, 6, 7 columns, each one with different offset values. Now let's finish adding some CSS classes so that we can have a nice indication when we hover each column. So let's go back to the styles, and in the column class, let's say top 0 to align the divs completely to the top. Let's give them a width of 50 pixels and a height of 100%. Now let's give it a background color of transparent for now, and then we will change that when we hover on each div. We can do that by adding another class of column hover and then setting the background color to an RGB value. Actually it's RGBA, so that we can give it an alpha as well. So red will be 255, 255 for green, and 255 for blue. That'll make it white, and let's give it an alpha value of 0.2. Okay, let's see how that works. If we go back to the browser and hover on each column, you can see that it changes color, and we now have a nice indication of what column we want to select. There are, however, a couple of things that I would like to change. For example, I want the cursor to change to a hand to give a better indication that you can actually click the column, and also smooth the transition of the hover effect. So let's go and do those things in the editor. Down in the styles, let's find the hover effect here, and let's do cursor pointer, and that will change the cursor once we hover in the column. And also let's add a transition for the hover effect. For that, we go back to the column class, and then we say transition, and here we specify the property that we want to use for the transition. In this case, it's the background color. Next to it, we specify the time we want the transition to last. In this case, I'm just going to use maybe 0.1 seconds. And finally, we want to give this a transition animation or a curve for the animation. In this case, I want to use is in and out. Let's save this and go back to the browser. Now if we hover over the column, the transition is a little bit less harsh, and we have this hand indicator. Now let's make it so that when we click a column, we actually drop a piece into that column. Back to the editor. And from the previous video, we already have this take turn method over here in our component, which actually drops a piece in a selected column. We were using it with the basic UI, but now we want to use this same method, but every time we click on a column. So we have to do two things. First, we have to accept a parameter in this method, which is going to be the column that we selected, or the column that we actually click on, which means that we no longer need this column property in the component, so we can remove it. And then let's go up to the template. Let's remove the input and the button. Although I am going to select this click property and copy it, because we are going to use that in our columns. So remove the input and the button. We no longer need that. And down in this div, that is the one that is rendered for each column, we are going to add the click property. Now we do have to pass the column here, which we already have in from the v4. Now we are not going to send the column because that is just the value for that column. So it's either 0, 1, or 2, depending on what we have at the moment in that column. So that is not useful. What we are going to send is the column index. And I think that should be enough. Let's save this and go back to the browser. And seems to be complaining about the column, saying it's defined but never used. Let's see what's happening here. I take a column. Oh, okay. So I'm using this column, but this is no longer a component property, so we have to take that out. So I'm going to select this, all of the instances of this column, and then remove the this dot from the beginning. So we just have column, column, and column here. Let's see if that works. Save that, and looks like the error is gone. So let's see if we can drop a piece in the board, clicking on the column, and there you have it. Player 1, then it's player 2, player 1 again, 2, 1, 2, and 1. Now, we still don't have a winning state, so I can just keep dropping pieces in the board like this until I fill up the board completely. So this is what we are going to do next. We are going to find a winning state for whenever a player gets a 4 in a row, and we are going to end the game right there. So back to the editor, and let's open the connect4 file, the connect4.js, and we are going to add a new function that is going to determine if there is a winner. So let's go down here and let's export a new function, and let's call it is winning move. This will take in the board and the color of the piece that was just dropped. Now we are going to take the easiest approach, which is to check all the board in all directions, which means that we are going to check all of the rows, all of the columns, and all the possible diagonals, upward diagonals and downward diagonals. And if we find 4 pieces in a row, we simply stop, return true, and end the game. So let's start by checking all of the rows. So check all rows. We will start by looping through all of the columns. So for, let's say, C equals 0, C less than row count. And here we are going to do something. We don't really have to check all the columns in every row. Let me show you why. For example, if we check this row right here, we can only connect 4 pieces in a row up until this point. So we can make one piece here, another one here, and another one here, and finally another one here. There is no need to check this from this point forward because there are only 3 columns left. So there is no way we can connect 4 pieces here. So we are going to check only column 0, 1, 2, 3, and we are going to stop there. And if you remember, row count is actually 6, so 6 minus 3 is 3. So row count minus 3, and that's all the columns we have to check. Then C++. Now we do have to check all of the rows, so let's do another loop. For let R equals 0, R less than row count R++. So what we check here, let me show you in the board again. If we are checking this row again and we are in this row and column position, we just have to check the position that we are at plus this one, and this one. So we check these 4, and if they are the same color, that means that we have a winner there. And if not, then we move to the next one and do the same thing. Check this one, the one next to it, this one, and this one, and if we have the same color on those, then we have a winner, and we do the same thing for each of those up until this point right here. So here we just have to do an if board in that row and column equals to color and the one next to it, which is board, the same row, but we add 1 to the column. So C plus 1 equals to color as well. And then we do the next one, and board row C plus 2, column plus 2 equals to color. And this line is getting a little bit too long, so I'm going to format it a little bit more. So add this here and move this one below and this one as well, like so. And we check 3. Now we just have to check the last one and copy this, paste it here, and column plus 3. So if this condition is true, then we have a winner, so we just have to return true. And we don't need this and at the end, like so. Okay, that will do it for all the rows. In fact, let's just test it out real quick. I'm going to save this. And we have to actually use this function. So let's go back to our component. And in our take turn, I'm going to remove this console log. We don't need to see the board in the log anymore. So right after we drop a piece, we have to say if connect for is winning move, and we pass the board and the color, and this is actually this board. And for now, let's just say console log we have a winner, just to see if it works. Save that. Back to the browser, and let's drop a piece here, and then player 2 up on top of it, and then another one here, another one here, and let's actually open the console before we drop the last one. And if we drop another one here, then we get the message that we have a winner. Now we haven't stopped the game yet, so we probably need some sort of variable that will let us know that the game is over, so we won't take any input from the players. So let's do that. Back in our component, I'm going to remove this line from the created method as well. We don't want to see the board in the console anymore. And let's add another property called game over, which is going to be false by default. Now here we can just set it to true when we have a winner. So this game over equals to true, and just above it right here where we check if the column is valid, we can also check if the game is over. So if the game is not over, this game over, and the selected column is valid, then we can take the turn. So with that we save, and if we go back to the browser, I'm going to clear the console and then do the same thing. We have a winner there, and if we click anywhere we cannot keep going. And the player label still changed, so we should put that inside the if as well. Or actually, let's just make an else statement here, and there we will change the turn. So cut that from here and move it up here. So basically we don't change the turn label if we have a winner in that move. And since we are at it, let's also add another label letting the player know who won the game. So let's go up to the template, and this h4, which is the label for the player's turn, should only show when the game is not over. So let's do vShow not game over, and let's add another one. So I'm going to copy this one and add one just below it with the vShow, but in this case it will be game over. So this one will show when the game is over. These spans can stay the same, but at the end, right after the span, we are going to say wins. So this one will basically say player 1 or player 2 wins. So let's save that, and let's go to the browser to see it working. Let's win the game here, player 2, and then player 1 wins over here, and we have a winner, and we cannot keep going. Okay, so we have the winning state for all the rows. Now let's do the columns. So back in our component, actually no, in our Connect4.js is winning move. Right over here, let's say check all columns. Now we are going to loop over all of the columns. So for let c equals 0, c less than column count, and I just spotted an error here. This is not row count, this is column count. Do we have a column count actually? Let me check. We don't. we need a column count as a constant up here. So const column count equals 7. Okay, back to the winning move method. So we go from column 0 up until column count C++. Now here we do have to check all of the columns, but with the rows, let me show you with the board. As I said, we do have to check all of the columns, but we are only going to count up in the rows from the bottom, which is row index 5 here. We are going to count up 1, 2, 3, 4, but we are only going to do it up until this point, this index here, which will be 5, 4, 3. We don't have to count from index 2 because there is no way we can have a connect 4 from this point upward. So let's go back to the code and it will look like this. For let r equals row count minus 1, because remember we are counting from the bottom, which is the last row, which in this case is index 5. So we initialize the row in the last index, and then we say r is greater than or equal to row count minus 3, r minus minus, because we are going backwards. Now I'm going to copy this if from up here, copy, and I'm going to paste it here because the logic is very similar, except that we are not going to move the columns. So let's remove the +2, +1, +2, and +3. And we are going to move backwards on the row. So our row and column here, and then r minus 1. Actually, let's leave it like that. Then r minus 2 and r minus 3. Okay, let's save that and test it. Back to the browser, let's drop a piece here and then another here, and let's just win the game for player 1. As soon as we drop it here, we have winner, player 1 wins, perfect, and we cannot click anywhere else. Okay, now that we have the rows and the columns, next we are going to check for the upward diagonals. And again, we are going to use the same logic here because we are going to only check up until this point in the columns, and also we are only going to check up until this row here because again that's the last place we can get an upward diagonal in the rows. So for example here, 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 and here. So right after this for loop, let's do another one. Let's say check all upward diagonals. And I am actually going to copy this for loop here because the logic is very similar. Only that we do have to check, we do have to do a -3 in this for here because we are only going to check up until the column count -3, and these for loops stay the same for the rows. We only check from 5 up until row count -3, and down here we just have to add 1 to each column, so C plus 1, C plus 2, and C plus 3. So let's save this and test it out. Back to the browser and let's see, let's drop one piece here and then another one for player 2, then player 1 here, then player 2 here, and let's see, let's drop another one here for player 1, player 2, then player 1 again. Now I have to fill this row here, so let's say player 2, player 1, player 2, and if we drop another one here, then player 1 wins. Perfect. So now we have all of the rows, all of the columns, and all of the upward diagonals. Finally, we just have to do the downward diagonals, which at this point is very similar to what we have been doing. We are going to count all the columns up until column 3 over here, 0, 1, 2, 3, because from there on, that's the only place we can have a downward diagonal. And same thing for the rows, although for the rows we are going to count from index 0 up until index 3, because from there on that's the only place we can have a downward diagonal right here. So let's go see how this looks in the code. I'm going to copy the logic for the upward diagonals and then paste it down here. Check all downward diagonals. Now the columns, we go from 0 up until column count -3, that stays the same. Now for the rows, we are going to start at 0 and we are going to go up to, so r is less than row count -3 and r++ because we are going up. And here we just have to do +1 on the rows, and I think that's it. Okay, let's save that and test it out. So let's see, let's drop a piece here and then here, another one here, and then another one here, here, player 2, then player 1, now player 2, player 1, player 2, player 1, player 1, player 2, and now if I drop one here, we should have player 1 wins and we end the game. But before we go, I would like to add a button down here so that we can reset the board and then play again. So back to the component in the template. Let's see, I want to put it right below the board. So maybe below the wrapper. So it'll be the closing template tag and then one closing div. And just above that one, we add a button. This will be type button. We only want to show this button when the game is over, so we show game over. And let's give it a click method. And let's call a method called reset board. And we are going to create that method in just a second. And for the label, let's just say reset board. Okay, let's create this reset board method down in our component methods. Let's add a new one up here. Let's say reset board. Don't forget the comma at the end. And here we can just say this board equals connect for create board, which will basically clear out the board. Then we just have to set the game over variable to false. So this game over equals false, so we can keep playing. And finally, let's reset the turn to player 1. So this turn equals this player 1. And that should be it. So let's save this. And let's test it. Let's quickly win the game. Player 1 wins, and we have a button here that shows reset board, and if we click on it, we get a brand new board and we can continue playing. Okay, we are going to stop here for this lesson. We have a functional connect for game, which can be played by two people alternating turns. In the next video, we are going to start working on the AI, and we are going to take a simple approach where the computer will try to select the next best column based on the current state of the board.